Hello, everyone. Hello. In this video, what I'm going to do is I'm going to describe the core abstraction of this simulation software, LiteDD. That's a Light Digital Direct. So, though there are a lot of implementation details, are you getting me? Like combinational circuits, flip-flop, gated latches, and some other sequential circuits, like clocks and the software itself is a simulation software. I'm using Visual Studio to run the program. So you have an app here, and you have access to some of these combinational circuits. Like for example, if I select that of a 4-bit adder, you see some kind of information here that shows like the process on how, or like a simulation. I get me the inputs, the outputs, and look in like internally how it was able to do those stuff, adding this bit and carry it. So in this video, we're not going to look at all the implementation details. What we're looking at is the abstraction. So though some of the abstraction might have few implementations, but basically it's like defining the entire structure of the project or how different classes, how they interact with each other, their relationship, like inheritance. For example, now unit is an I digital. Um, it inherits from this other class, I digital. What are the different types of classes? This one's a language construct. Like for example, we have interface class. What is an interface class? It's a class that you can only define properties and methods. So properties, that's to say you have like a portal or like an opening to the outside world so that you can either use those properties to set values in a class or get values from a class. So they can be function itself or just attached to a variable. Some of them can just be read from only functions or write only functions or even read write functions. So we use the terminology getter and setter. So if it's both the getter and setter, it's read write. If it's getter, is read only, and if it's set, is write only. So we can have a concrete abstract class. Abstract class now have can have some implementations like methods that are already implemented. It can have constructors. It can also have this thing attributes. So attributes are like variables attached to it. But usually for as a standard OOP concept or a technique, we don't usually allow attributes to be accessible like that. We make use of properties around them. But internally, you can have private attributes that the class can use or protected attributes such that when you inherit the class, the child class can also access such variables. So we call them those ones protected. Then we have concrete classes. Concrete classes are now the ones you can create instances of. Like for example, now you can create an instance of a pin. You can create an instance of a signal or an event or a daemon. They are all concrete classes. You can make use of them. But an abstract class, you cannot um, instantiate such classes. You have to have another class, inherit from such classes, and probably implement all those abstract methods or abstract functions that is already in the parent class. So, though there might be some implementations, but if there is no implementation, the child class have to create an override. It has to override such function or give implementation for it. Override is when it has been implemented before, but if it has not been implemented, you have to give implementation for it. So, and some classes, like for example, this clock can inherit from two. It's more of a concept of mixing. So you can inherit from two other classes. Like now, it's using inheriting from I-driven unit and module. So that's to say, it's an instance of this, and it's a child class of both this and this. And you can use polymorphism to probably cast this one to this type and use some of the properties, etc. And it's just to indicate that this module, any class that is created like as a clock, it means that it's a module, but its type also is an um, event-driven unit. So it can be driven with events. All these things are what we're going to treat in this video. So starting from the very fundamental, very basic. So if you come into this like folder structure, so all these other aspects of clocks and they are all implementation. Those ones are like the actual computations or where some raw calculations are being done or processes are being done. So those ones are like the implementation of this, but all this denotes the structure or the abstraction, the layers of abstraction in this program, of which every other thing is built on. Like gates now, we cannot just use gates. You have to have implementations of gates, and examples of that would be like and, nor, XOR, etc. So, but all those abstraction make the building or the development from there a lot more easier. So, from what I see here, this one is just like the core aspect, and this TestDD is kind of a UI wrapper around that core. So basically, you are importing some of those stuff that have been implemented in the core aspect and having UI interact with those programs. So you don't necessarily need to typing them out or code writing a simulation script or something like that. Just from that platform, you can do all those simulation. So now let's first start with iDigital. iDigital is basic class. So if you come to iDigital, we're going to brush through it. So basically now it's a public interface. You get me? So what it defines two a method. I mean declares a method. When I say define, that's to say you have given or implement, you have given like the body of the method. But when I say declare, it means that you just like give it the what do you call this thing? The function identity or declare the function. Just know what is its return type and the type of its input. So this DRV conceptually is like every other gate we have a DRV function that's like a driver function that can actually do allow signals to flow inside that gate or inside that unit or inside that module because all of them in one way or the other are still digital classes. They still inherit from them, so they will still share all those properties. So for example, now an XOR gate, you have input signals at each of its pins. So you want to allow it to flow based on the rules of that gate so that it can give an output or a clock signal. You want it to like either maybe create a square wave pulse or something based on certain events. You have different type of clocks, etc. So it must have a driver function. So that's why all ID digital they have driver function. Then now what is this string ID? It's just like a unique ID. I don't need to explain this one that much. But this is a property. That's why you see a get and set. So it means that you can both retrieve this property and also set this property. So it's a read write stuff. So now we have another class which is abstract. So abstract now inherits from iDigital. So I'll go now to abstract. I mean unit. So what is a unit? So this is an abstract class inheriting from iDigital. In its constructor, what you are passing in is number of inputs. What's the size of this input? So basically the base when you call base in C sharp, it means that it's going to be calling the constructor from the parent class. So it's just like in Python when you do super dot underscore init. So you are calling the initialization function or the constructor of the super class. So now you are is declaring an array of pins. So I'm still going to explain what pins are. But in this case, this input now creating an array of pins based on the number of inputs. It also declares this function so as an abstract class, abstract method. So basically, it means it's still there so that other classes or other classes that we see inherit from units, we get to implement their own DRV function. So for all gates, XOR, all of them have their different DRV function based on how they work. So we have another function property here because it's from an interface class. It means that you have to still repeat it here again. So now it's a property, not an abstract. It's a property now. So what's this input sig? Input sig is just is a read only property. That's to say you get like the signal in a summarized form. So instead of you having an array of pins, so each of those pins has a signal attached to them, which could be high, that's one, low, zero, or undefined u. So those are defined as characters. So input sig is a property that's going to return to you a array of characters. So that's why you see under the setter, you first use the length of the input. You assert if the value dot length. So the value dot length. This this is a write only function. Sorry, when you use a write only function, it has a setter. This when you are writing by default, C sharp give you access to value. This variable value. So value is actually what you are passing into this. It's just like, for example, I have an instance of this unit. For example, ZOR. ZOR is a unit, for example, now, and I say ZOR input sig is equal to. So instead of me having to like be creating those classes, I can just manually type in all those like one u let me use zero. So now, but this is the thing here. This is I see this is a syntax error, but just ignore it, sha. So let me comment out this one. So what was when you are doing this you are using the setter function. So now you are going to like use this property to be able to affect what input this variable that was created inside, what it contains. So the list of arrays, or I mean the array of characters that are going to pass into this setter must have the same length with the number of inputs that you have used to declare that XOR. Like for example, a simple XOR gate should have two inputs. So whenever you are doing operation that you want to change the input signal, for example, I want to do XOR on 1 and 0, this is what I should pass into the function. I get it. So it's just loop through it and ensure that the signal of each of the individual pins in the list of pins or the array of pins are set to um, that particular character. So the signal, I'm still going to explain what signal stuff like that. So, but that's just the idea of what this setting property does. And this is also a getter. That's just to retrieve what is in input. So rather than just directly making input a private public class that you can just manipulate anyhow, it's better you always use them around properties so that um, the whole thing is well encapsulated, which is also another pillar of object-oriented programming. So yeah, you have in unit. So I'm going to go towards this side and explain what the signal and the pin is. So though these ones are standalone classes, they don't inherit from each other, but they have some logical resemblance or like some linking to each other. So I'm going to explain that. First thing I'll talk about now is that of a signal. So this signal in itself, it's more of let's think of it as the like what's passing through a wire or passing through a pin or a connection in any gate whatsoever. So it can have three states. Internally, we define those states using with this character C. Not we, I mean the lecturer that wrote this program. So define this character with C. That's using null. So null is also what used to represent undefined when the like the state is not yet determined. So we have this random for it's basically using the random number generator from C sharp. So I believe it's a uniform random number generator. So basically using a time dependent default seed value. So it's just going to be random. The goal is so that you can generate random signal. Like when you use this property, I think where's the property? So if you call this, if you use this class, that's like signal dot random, it will return a random car. That's this character. So it uses that random number generator to create a next double, and if that double, because it can be between 0 to 1. So if it's less than 0 point or equals to 0.5, it will output 0, and if it's greater than 9, it will output 1. So it can either be up to 2. And this is a static class, so it means I don't need to instantiate static method. You don't need to instantiate the class before using it. You can just directly use it on the class. So what does this aspect do is also another property, a getter property. So when you want to get the value itself, like that actual C, you don't have access to C. It's a private character. So and this question mark means that it's nullable. So it can also contain null. This automatically converts it. So if C is equal to null, I'll put this else use C dot value, which is basically what's inside character actually. So C is a character, so yeah, value. But this dot value actually it has a different connotation because when you use dot value, what C sharp will do is that it converts it first to a signal, then now uses where is that? I think I've seen it somewhere. But anyways, if I define it in such a way to have like a recursive nature. So, but I think that's what's defined for character by default. And that's a dot value property. This is also another getter. So these two lines of code here, static, implicit. What do they do? They ensure whenever you want to use a character as a signal, C sharp can convert it to a signal and also convert it back from a signal to a character. So that's if you have character maybe conversion on it, whether it's implicit or sometimes explicit, it will take the signal and give out the value, which is a character. And if it's a signal, I mean, if it's a character you want to convert to a signal, it will construct a new signal based on it using this constructor. So this is what is demonstrated here. So you can see It's a concrete class. Value property can be it has support for implicit conversion. So now, what I'm going to talk about now is all these static methods. These static methods are very powerful. It's like you can use them for a lot of operations on it. Like this function now, count once, is basically based on a list of characters or an array of. Now, instead of me just using characters now, I'm going to be using signal interchangeably with them because a character can be a signal and a signal can be like a character. So because of that, easy conversion between the both of them. So basically, what it's doing is that it counts the number of characters that are set to one, and this one are the ones that are not set. So zeros, count the number of zeros in that array of characters, and to always to return an int. So in the case of pass, you might wonder what does this code do. Basically, you are giving an integer. For example, now I'm giving 23. Let me use this. So for, let me something. Maybe I'm giving an integer one this certain number, and the number of bits I want to represent from this. Maybe I want to take the first 10 bits. So the number itself, it's represented in binary. If I want to get the binary representation, let me use the Python to keep it up. What is the number again? 2, 2, 3, 4, 3, 2. So this is the binary representation. What this 10 does is that what does this number of bits 10? It creates an array of characters based on this last 10 values. Like from here, from here to I think this 5 already. Yeah. So you have an array containing 1, 1, 1, 0, 0, 0, 1, 0, 0, 0, 0. So that's what it's going to do. So in the internal working, this division by 2 is basically like shifting it. Because you can also think of it as like a left shift operator by 1. I mean, this is my left, this is my okay, right shift by 1. So basically, like that's what that division by 2 does. Then so if you look at this code, what does it does an assertion first. The reason is because if I do 2 raised to the number of bits, for example, now I want to extract 10 bits out of a number like 512. So 2 raised to 10 will give me 1024, and the maximum value in such number of bits, that's when everything sets to 1, will now be 1023, 1024 minus 1. So if that maximum is now less than what is in x, like 1000 can what am I saying? Yeah, x in itself is greater than, oh yeah, if x is actually greater than that maximum, like in the case whereby I wanted to use that, so that's not actually going to work. This is the one that's even feasible. So if it's more than 10, it will not work actually. So it's just that those other ones that are less than that set number of bits, like for example 1023, means that all those other bits after when it's filled up will be 0, 0, 0, 0, 0, 0. Will all be 0. So that's why that's what this condition does. I think I even read it actually. So if it's less than, I mean, yeah, if x is greater than the maximum that you can form, so it will raise an exception because you're trying to like fit a bigger number inside that set of bits, which is not possible. So you create an array of characters based on the size of the bits. Then you have some variables here, which is n and r. That n is basically like at every step x should be shifting. So if it were to be that maybe the initial binary representation of x was 1 1 0 1 1 0 0, something like this. So in the first iteration, this 0 will be chopped off. In the next iteration, it will be like this, just like that, 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 until n is equal to 0. So and also we can get what's at the last value using modulo. This modulo will now get what's at the last value. So if r is equals to 0, you use the character representation. If it's equals to 1, you use this character representation. So that's how you do that, and you reset x to what n is, so that in the next situation you have to shift it again, just like that. So that's how you take a number, an integer, and you convert it into an array of characters. Then you have also this random. Okay, I think I've explained that. So to int, you have a list of characters and want to get back the binary representation of it, and this is very, very straightforward. If I have a number like 1 0 1 1 0, basically I should just know its step. Like for example, now I'm iterating from I. So 0 at I, this should be I'll just do 2 raised to power 0. 2 raised to power 0 is 1 times 2 raised to power 0 is 1. But in the case where it's 0, you don't need to add anything. That's why it says break when the case is 0. So when it's 1, it will now be 2 raised to power. So this will now be This one now will be representing 2 raised to power 1, which is 2. Then you plus it with 2 raised to power 2, which is 4, plus this will be 2 raised to power 4, which is 16. So that will give me the integer representation of that array of characters or array of bits, as you see here, and to return it as an int. So they will ensure to they started with a double because of we are using the max power function, which uses a double. But I believe like if I were to do this implementation, I should use the left shift operator rather than using doubles, so that you don't have any bug. I think this is even going to be like an intending bug or something. So yeah, because computers don't really, there is some kind of inaccuracy when it comes to doubles. So only use doubles when there is no other way for you to use an int. So direct manipulation on int are always better. Because if I want to do this raised to power in integer, it's just basically taking one and left shifting it by I. So if I take this as an int now, I'll just be doing one left shift by I. So that's the same thing as doing 2 raised to power I. So let me leave the code the way it was. Sorry. So now you have another one here, which is dot t. T is going to operate on string, string dot character array. Okay, to take a string and turn it into an array of character. Yeah, it's also a static method too. Yeah. So instead of, if I can probably have something like this, maybe a string of my signals or something. Wait. So I can have an array of my so and use it to convert it to a character array using this static method T. Then this to string is just like to give it a binary representation. I mean, a description of these bits. So I think it spaces it with dots, something like that. So you go through all of them and put dots in between them. So just to represent what those bits are. Then this to string override. This one now is an actual class, not a static class, so method. So it's going to be calling on a signal instance. So when you use the string, maybe you want to print the value or something like that, automatically to call this to string. So it will replace it with what it actually is like in a string form. So yeah, I think that was for signal. I'm just gonna control Z everything. So the code base is as neat as that. So now what's pin? Pin is just like a wrapper around that's the same way explanation I use here. A wrapper around the signal with get and setter. So you just have by default the signal, which is a property here set to undefined. Then you can also you have another constructor here where you can declare the pin using its bits. So that's what we use to construct it. So you have two constructors here. I think even based on what this guy Visual Studio is saying, means that this style has not even been used at all. So but this one has about 63 references. So this other signal, this one are get and setter, so you can retrieve the signal or set the signal through that. And this override is just so the pin itself will now be calling the signals to string function. So that's what it will use to represent its own string representation of that class. Yeah, when you have an instance, you're going to know the string representation of that instance. So this is the function that does that. So you use the override keyword because you are like replacing an implementation that's already since it's not inheriting from anything. Actually, this override keyword, oh yeah, it's inheriting from like the default is inheriting from the default object function. Like if any class is inheriting by default, though you don't do that by yourself. By default, it's inheriting from like the main object that comes from C#. So all of them have their toString function by default. That's why you have to use override here. So from there now, I'll go now to I've talked about the unit abstract class. So all these classes now are separate. So we use those classes now, we use them to do some sort of implementation in some of these other classes. So like especially input and signal, pin and signal. So pin is just like a connector on a gate or a module or a unit, while signal is the value that flows through it. So you can think of pin and signals as almost the same thing because this pin itself is just a wrap around it. But it's better because now we can have multiple, maybe like for example now you want to change the program to have some different form of signals passing through the pin, maybe like an analog signal or something through for other non-analog analog circuits, etc. you can easily change it without have to destroy the entire pin structure. So yeah, that's just that's just it. But whenever you're building software, you have future updates in mind. So this is a this is a good proper software architecture. So you don't get confused later on in the into your building. Right? Yeah. So now I'm going to describe the module. The module is not really, it's just inheriting from unit. I think I've explained what unit is. If I'm not mistaken. Yeah. So you have input into it, and you can either convert the set the input using this input seek property or get from there. So yeah, this module is just a, it inherits from unit, and it calls the unit constructor. So all the same properties of units, it just inherits. It's just like another name for unit, but you have this name for some certain reason, sha. So it's okay like that. Or probably they see room for some other implementation based on modules in future updates of this program. So yeah, that's for module. Then for circuits, this is where things gets more interesting. So I'm going to read what I have here first. Let me. I'm gonna share this description. Um, I'm going to share this in the description below. So I'm going to send it in the description below. You'll find it there. You have stores. Okay, it's an abstract class. That's first. So I think I've explained what abstract class is. You cannot make use of them. You have to still have another um, class inherit from it. Then maybe declare it as a concrete class. So it stores all component units that make up the circuit in a list. So basically, a circuit is a unit itself that can house other units. Like for example, now if I'm designing a latch we have, it can be made with NAND gates. So it's going to contain units such as NAND gates, and also it might be maybe constructed with AND and NOR gates. So a circuit now can have multiple units under them. Like for example, too, an half adder now will be constructed with EXO and AND gates. So a circuit is a unit that can contain other units. I don't know if that makes sense. So if you see the code here, you have ID list. This ID list is just so that it can be indexed, but it's basically the same thing as a typical C# list. So you have it calling the constructor from the unit class. Then this add now, you can add parameters. These parameters is just like in Python you have args. You use args, star args. So it means that you don't necessarily know the size of the input. So you can call add on maybe even an empty list, which is not normal to do actually. But you can have it call maybe like something like this. But this will be on an instance though, maybe the child instance. For example, now you have an XOR gate and you want to add dot add maybe a NAND. I mean, XOR uses and you want to add a what do you call this? This one will be an instance. You want to add and um, not. So an XOR gate uses and not and or also. So like this, I'm just giving an illustration. So this is what it can have variable size of parameters that you put in there. So you can put in one parameter, two parameters, this that. That's why you use this parameter tag. So, but it's going to internally list them as a list of units. So all the parameters that you're supposed to put inside this add method must be they must be what do you call it? They must be units, instances of units, whether probably instances of circuits too, because you can have list of circuits making up another circuit. So yeah, that hierarchy also increases. Like for example, now is an XOR gate now probably as a circuit, though you can implement it as a unit, but as a circuit, you can use those other XOR gates to make other stuff. Or probably you made a memory chip, just one memory chip. You can now use it to probably make a register, which is also another circuit. Then that circuit as a register, you can use it to form a what do you call it? A RAM chip of maybe like a 8 bit RAM chip. Then from there, use it to form a 62 I say bits, 62 bytes, 2 bytes. Yeah. So just like that, maybe 8 registers stacked together to form another RAM chip. Just like that, just like that, just like that. so you can get to build bigger. And since it's growing exponentially, in probably like its definition, you can get it up to probably like 32K or 64K RAM chip or something. So, or RAM circuits. Let me use the terminologies that the class this could use. So I'm protected. I believe you know what protected is. That's to say, let me explain. Protected means other people classes outside will not be able to access that method except the children of such class. Like for example, I think memory inherits from circuit, so memory will be able to access that add method, but other classes outside of it that want to make use of it will not just be able to add by themselves. They will not be able to add chips to it actually. So this DRV function is just to drive. So basically all the units of that circuit already have their own drive function. So for you to drive the entire circuit, you just drive all the individual units. That's what the logic just does. So it drives them sequentially. So when you are also creating the circuits, you would have stacked all those units in such a way that they have their, let's say, logical order, or what you can call the flow of signal, how the flow of signal will move. Are you getting me? So that's what this I believe this sealed means that you cannot really change it again. Something. So I don't really need why there might not be any other logic to how to approach this because this is just what you should do. So probably I may not be sure exactly. Let me see from the references whether there's any class that changes it. So from what I'm seeing here, nobody changes the DRV function. It's not changed. So yeah, you see unit. So what this unit does in essence is just giving the ID. You want to like fetch the particular unit inside that circuit based on its ID. So it's just set through based on the size of that u.count. What is the size? Then if the ID is equal to null, just continue. But if it's you do a string comparison to the ID. So if it's equal to 0, that's to say they are equal. So, like if you have matched the ID with the particular unit, just return that particular unit. And if you search through everything, you do not find it, throw an exception, throw a tantrum. So, why would you be searching for what does not exist? So, and this other function, this is my wire pins. This wire pins now is the abstract method. That's to say, you just declare it. So, you have to implement wire pins for each of the gates you're making. So, but logically, what the wire pins is like doing the physical connection with code for those inside the gate, no, inside the circuit. So now, if you have like, for example, you're trying to implement, you're trying to implement, okay. So now in this wire pins, you are doing the physical connection. Now I'm creating a full adder, and I've created an half adder chip already. So theoretically we know that we have to join those two half adder chips to make a full adder chip. But how to do those linking, which input pin should go to this input pin, just like that. That's where you do this in wire pins. You do that here. So for each of those other gates that you build, they will all have their own implementation of wire pins function. Like for example, if I check here, you can see add sub bit for I have an override that tells okay how I do the wire pins connection for that. I think maybe we should just check it so that you can see. Let me click this one. So you can under the wire pins function, you see it makes use of XOR and stuff like that, and also another full adder. So that's what it uses to see all the linking. Like the input of this one is connected to M, the input of this is now connected to the input of 4, etc. Just like that. So basically you are coding all those your wires in your diagram. So you have drawn the diagram on paper first, and you now write all this code to like do the connection of all those individual components also to the input of the entire circuit and the output of the entire circuit. So basically that's what that function does. Then you have memory class is just like is similar behaves similar to the most common latch, which is like an SR latch. So if I come to memory, you just basically have it's inherited from circuits, number of inputs. So these two properties, which are public properties, these are pins. So they can have signals inside them actually just the same way I've described before. So this is Q and not Q. So basically they're just opposite of each other. If Q is true, the other one should be false. If false is they're just opposite of each other. So these they just have two functions. They are static functions. So it means that you call them in this format, something like this. You say memory memory dot reset on probably one instance, maybe M1 or something. So basically, it sets the Q signal to zero and sets the Q not signal to one. And if it's set, I'll set it to one. Just like that. So that's just basically what the Q memory class is about. So now I'm going to describe the gate. The gate is also a unit, but there's a uniqueness to the gate. So let me read what's here. So input has to be at most 4 bits. That's what was declared in the constructor. I saw that there's a if statement to ensure that. So it has an override string method that display the input stuff like that. So the only addition that you will see in the gate is that you have input and you have output also. So you have to define output also if you come to gate. That's yes. So it inherits from inputs. So you have number of inputs. Yeah, the same thing. So they check if number of inputs is less than one, that's zero, or even negative set, or number of inputs is greater than four. So you raise an exception. So I think you are limiting the logic. They are limiting the logic in this code base is limited to 4 bits. Even the other chips, they are 4 bits. Other chips and something. So they have an output property here now. So just one output. That's just which is a getter. So you see by default is equal to new pin. So it constructs a new pin, which is set to zero. So but all this is not it's still an abstract class. Some other gates can have multiple input, multiple output. So you get to still manipulate all this data. So but also you have override string here. This also represents the gates, and gates are combinational logic. So it means that as such input you can immediately have the output. So you just a formatting. I think I even typed out how the format will be like. So you have the ID, you have this arrow pointing to input. So the actual values of those inputs will now be arranged to each other, and the output of the gate will be like this. So this is like a string representation. So if you want to like print out that gate, you have something like that. I think I should be able to demonstrate it. So let me run this program. I think. Okay. So if I come here to let me look for a combinational a gate. No, let me use a latch. Let me check a latch. Let's say the latch. So you can see this was oh, this one is X is I think for enable. Let me look for some. I think I saw when that represented input and output. No, I don't think it. Let me see. Okay, I think maybe this. Still doesn't. Maybe it was not used yet. So I'm only seeing 8 references to this. So I think this for now. So those gates, I don't think they are even implemented. They have been implemented, but they have not have access to the UI yet. So probably in the future updates, you might have that. These are very cool software actually. I think there are other existing simulators, but this one seems promising. Um, so I think I've explained out of the gate. Straightforward. That's also under structure. So before I start to talk about this one, I'm going to just the clock. I'm just going to talk about this I events driven. So if there would have been a pattern anytime you see an interface class, it usually starts with I. So this event driven unit is more of like a mixing that just indicates for that class that it's something that should use events to operate. So indicates that a unit has to be controlled by an event, and it declares an exe method that manages the events related to the unit. So some devices, especially that no, not especially, typically sequential circuits, they make use of events. So probably an event it can be level triggered or what do you call this? Edge triggered, and it might be maybe the positively edge triggered, maybe in the rising of the signal, the square wave pulse, or the negative edge triggered, which is on the falling aspect of the signal. So there are different events. Maybe it can even be expanded or something, maybe a value changing or something like that. So that's the case of IGV. So any other class that will be created that will need to use events will be is we inherit two from this class. So let me check the IDV unit.exe. So basically, it's just its execute event. So it just uses to execute events. So that's like the engine of the event. So now I'm going to explain this aspect. There are two aspects here: events and demo. So this stuff, if you come to events, what is this event? Events is this one. Um, it just it's self-explanatory in its terminology. So it will contain. It's like we have different type of events. So there are properties um, that are defined for an event. So when you're constructing the event, you have time, which is a double, that the type and the units that is associated to this event. So and what's this iClonable? iClonable is just is inheriting from the system library. It comes with iClonable. That's to say the class can be cloned. So that's when you see public which return an object clone. So it means that when there's some values that you want to be passed, this is what we call pass by value and pass by reference. So you don't want to be passing by reference right, every time. So you want a separate copy or yeah, copy or a clone. So it's create another one. That I say this new. It's create a newer one based on the parameters of the other one. So and you have properties. These ones are all read only properties. So after creating an event, you should not be able to change its time, its type, or its unit. No, you shouldn't be able to do that. So what's this day? This daemon, although it does not you inherit necessarily from another class, but it uses the event. So basically, this is like it uses a queue of events. You can think of it as a queue. So it means that you can add events to the queue, and whenever it wants to execute the one at the top of the queue. So it's like a line. The person that is at front. So that's I think you can call it the what do you want to say? uh, I think that will be first in, first out, FIFO. Yeah, first in, first out. So the first to get into the queue will be the first to operated on. So that's why I see this list of events, and it's also a property. It's a property, so it's gets and sets. It's a read write property. So you have this static void, which is this daemon is not really designed to be used as a instance. You don't need to create an instance of a daemon or have multiple daemons. You just have one class that does it for the entire program or the entire code base. So even if there are events from clocks or other combinational circuit, RAM, etc, memory chips, even CPU, maybe if you are doing an ALU, you're connected to CPU, you have like program counters, 3-bit counters, etc. Uh-huh. All those are going to have managed, their events are going to be managed by this singular class. As you see, almost all the properties are declared as static. So this add event just basically add an event to the list, the queue of events. Then this clear event just empties all the content of the event class. Then get next event, it's like does a pop operation. So it first access what's at the beginning of the event queue and removes it. So basically, I want to operate on it, and I'll get the next one, then operate on it. Then this pick next unit is just to like see what is in there, but not necessarily removing it. But if you notice something, this event is going to be created with a unit. So that's why you see events at 0 dot unit. So it's so but the unit itself must be will be casted, will be typecasted into an I-driven unit. Reason is so that when you want to maybe you pick, you can manipulate it with the exe function. So this is a clear example of typecasting or the use of polymorphism. I get it. Then this dot now is just saying, okay, what's the time of the event at the top of the list. I think that's what I talked about here. So the now property is simply the time of the event at the top of the event queue. Then implements pick next unit that returns the unit of the event at the top of the event queue casted as an given event. So that's just I think I've explained this so inherits from system by clonable class. So instances are straightforward. So the only thing to explain now is this particular clock. So just reading from here first. It's constructed using period and duty cycle. So basically you have something like can I write it pen here? Scratch pad. So let me cancel. Let me see if I can write it actually. So basically if you have a signal here, so you have, I believe, probably you might have treated. So now you have, sorry. You have this section. Maybe the signal also continues again. So the length, the time it takes for the cycle to repeat again is called the period. So this is the period. But now the duty cycle is like the ratio between when it's on and off. So if it's at 30% duty cycle, it means that at 30% of the time the signal is going to be on, and at 70% of the time it's going to be off. So you can calculate the time it will be on based on the duty cycle. So duty cycle usually use like 50, 60, just like that. So let me delete this. Anyways. Oh, forgotten I'm still writing. Let me copy it. So that's just what I want to explain. Okay. So okay. So now if I come to this clock, you can have a module I driven. Okay, so you need to focus on module and I driven unit. So you have two events here which are protected, and I've explained what protected is. You only children of that class, classes that inherit from it, can access them. So you have zero and which represents old event and new event. Thank God for this comment. If not, I would have checking if I get what that means. So so this double as though I believe the period duty cycle will be represented as a fraction. So if you are doing 50% duty cycle, it should be like 0.5. So this assertion is just basically to ensure that when I want to before the clock operates, is everything okay? So basically it will first check whether the enable pin if it's null or the signal is undefined. So that enable pin is more of like the pin that controls the um the class, I mean the clock. So if the enable is set to true, the pin is set to high. So it means that the clock should work. Or if not, the clock should just maintain its state. So this assertion is just okay, is everything good to go? So and also the causality effect. It has to say you should not have the time of the old event greater than that of the new event. So it means like maybe there's a some sort of time traveling somewhere. So you have to, it has to return false. Then if in every other case, just return true. So this output is what the output of the clock. So like that signal, digital signal I drew now should be like the output of the clock. Maybe when the clock is either high or low or something. So but by default, when you do get uh, just actually this clock is not meant to be used and instantiated. So like the declaration was just that it should be undefined. So maybe in an actual implementation of a clock, like if you come here, you can see some other clock like this dual PH clock, dual phase clock. So now you have on the output to be like a proper output. You get me? Like now this other one, quad phase clock. So this is the actual implementation of an example of a clock. So we'll treat that later. But this video I'm just talking about the core abstraction. So in this you have this clock sharp. Then the duty is just to get as a property. We don't change it later. Then this DRV is the driver. So this driving is going to just make use of like basically first assert whether it's true. Then if the signal is zero, just return, just don't do anything. But if the signal is set to one, you fetch what's the next event. So that next event is going to be created. It's an abstract method now. So but when you create an example of it, like for example this DRP, I believe you see you can see that's the next event that you actually get to create. So um so it will use that next event to get the next event actually. Then the new event will now become the old event. So that's why I say event convert. And there's always casting here, so that's to ensure if maybe the event has a sub, a child class or something, maybe like a trigger event or high event or something like that, it will go back to its parent, which is event. And yeah, and in those classes too, you can get to implement those methods as virtual methods so that the compiler can get to call the function attributed to it. That was, let me not go into those language details anyways. So now the new will be equal to the one you just created. So that's why you use clone. It's just like cloning. So you have copies of them. Then this executable, this one of using ex is now using the daemon, the event queue to do its operation. So if it's zero, just ignore it. Then if there's an assertion that is not true, ignore it. So the daemon gets the next event. You can remove the event from the queue, pop it out of the queue. Then it adds the event, this new event, to the end of the queue. So there might be other events in between actually. No, it doesn't matter. But now the old one will now be equal to what the new was. The new was. So that's just it. That's just it. Then this enable is by it's a public. That's a pin and we can is a get property. It's a get property. So it will give you um the input itself is a list of items, so which you have defined in even the base class, which is I think unit. So this enable pin is just a singular pin inside. inputs. But I think typically inputs contain only one item because in the constructor, if I'm not mistaken, you see call base with one. So it means that the size of the input is one. So just that one input is the same thing as your enable. So and this event next, this period is also getter. This resets to reset the clock. So they have maybe it's an abstract class, so there'll be implementation for the particular clock, how it's going to do its own resets. So probably to start its timing from the beginning or something else. And this string is just representing how it's built. So it's basically just imputing all these things using dollar sign operator. So time we put in was so, but what it uses to construct like the current state of the clock is the old event. So the time of the old event signal, like the output signal, I mean the signal of the clock, whether it's on high state or low state, then the type of the current event, maybe it's on whatever. So it depends. So I think I've gone to the core, yeah, I've gone to the core abstraction of this. So in the next video, we'll treat the implementation of each of those gates. Um, so for the simulation, we can use some of those gates that have already been made to like test out some programs, like use the hand gates and stuff like that. But I think from what I learned was I just get to understand what the code does. But we can still look at that. And I believe the intention of this program is not just so I can just be using code to do that. Um, you get to use graphical user interface to do that, or probably use another language as parser or something. But I think the device uses files or something, so you can track files, etc. So yeah, thank you very much. Continue with this video.